Welcome, Hornets, and thank you for joining me today. I am going to be going over the last three problems from our classwork from today. Since a lot of people did not finish it, I want to make sure that you have the support necessary to ensure that you get this done correctly. So we're going to be taking a look at numbers 3, 4, and 5. And for any individual who's not a member of my class, please take a moment and do a screenshot. Alrighty, let's go ahead and begin. So we're going to start by writing down the integration that we are working with. In this case, we are looking at the integral from 0 to 6 of x cubed plus 4x dx. We're going to start by finding delta x using b minus a divided by n. We're then going to find our c sub I, or x sub I, which is the x that we'll be using. It will be our first term a of let me rephrase that, the first limit of our integral, and it's the lower limit of integration, and then we're going to multiply by delta x times I. We're then going to construct the limit as n approaches infinity for delta x multiplied by the summation as I goes from 1 to n of f of c sub I. Alrighty, here we go. Let's do it. Our delta x is the gap between 0 and 6, which is 6 minus 0 divided by n. C sub I, or x sub I, the x that we're going to use, is going to be 0 plus 6i over n. We're going to simplify that to 6i over n. We're now going to construct our summation. The limit as n approaches infinity for 6 over n times the summation as I starts from 1 to n, and I now put in bracket, parenthesis, 6i over n, the quantity cubed, plus 4 times 6i over n. Now you'll notice that there is nothing to distribute here. There's nothing to FOIL. We just have to multiply, so we're going to start with 6 cubed. 6 cubed is 216. So I will have the limit as n approaches infinity for 6 over n, I starting at 1 and going to n, and I have my 216 I cubed over n cubed. Then, I have plus, not equals, plus, and I'm working with 4 times, 4 times 6, yeah, 4 times 6 is 24, and this is now I over n. There we go. Now we're going to take this piece and distribute to both so that I have the limit as n approaches infinity for 6 over n times 216 over n cubed times the summation of I cubed plus the limit as n approaches infinity for 6 over n. We're now going to put our 24 over n, and we have our summation of I. Alrighty. Now we're going to replace this. Now remember, according to the information that we've talked about in class, instead of working with every power of n, we only work with the highest power of n. That's n to the 4th over 4. This also only works with the highest power of n. That's n squared over 2. So we're going to directly substitute with those values. The limit as n approaches infinity, and I now am going to be left with 6 times 216, which is 1296 over n to the 4th times n to the 4th over 4, plus the limit as n approaches infinity for 6 times 24 is 144 over n squared times n squared divided by 2. N to the 4th cancels. N squared cancels, leaving me with 1296 divided by 4 plus 144 divided by 2, and this will give me 324 plus 72, and my answer is 396. Going and checking with my calculators, we should always do. I'm going to put math 9 from 0 up to 6, and inside the parentheses, I'm putting x cubed plus 4x. We're then going to put dx and hit enter. Notice we get the exact same answer. Let's now go to number 4, please. Number 4, for those of you who took a screenshot, you'll want to look at that and just copy it down. Otherwise, it's 2 to 9, the integration of 2 to 9 of 4x minus 5 dx. Our delta x is b minus a divided by n. Our c sub I, or x sub I, is a plus delta x times I, and we're trying to construct the limit as n approaches infinity for delta x. Let's make sure you can see that. Delta x summation of f of c sub I. Alrighty, so this is what we're going to work with. Let's go ahead and begin. Delta x is the gap. 9 minus 2 is 7 divided by n. C sub I, which is x sub I, is going to be 2 plus 7i over n. We're now going to construct the limit as n approaches infinity for our delta x, 7 over n, times the summation as I starts from 1 to n, and we're now going to put 4x sub I, 2 plus 7i over n, and then minus 5. So this is what we're going to simplify. I'm going to do it right down below, 8 minus 5 plus 28i over n. This leaves me with 28i over n plus 3. And I'm writing it in standard form to make my life easier. 7 over n, and we have the limit as n is approaching infinity. I'm now going to take this piece here and distribute it to both terms. As I do, I'm going to move the 28 over n out. Here we go. The limit as n approaches infinity for 7 over n times 28 over n times the summation of I, plus the limit as n approaches infinity for 7 over n times the summation I beginning at 1 to n of 3. Now, as we've said before, we're going to replace this with n squared over 2, and we're going to replace this with 3n. Here we go. The limit as n approaches infinity, and I'm now going to multiply, and I get 196 over n squared times n squared over 2, plus the limit as n approaches infinity for 7 over n times 3n. The n's are canceling, the n squareds are canceling, and when I simplify this, I end up with 196 divided by 2 plus 21. This is 98 plus 21, and my answer is 119. We're now going to go to our calculator and check our answer. Turn on your calculator and hit math 9, 2 up to 9, and inside the parenthesis, put 4x minus 5. Don't forget your dx, please. Hit enter. Notice we get 119. This leaves us only one last problem. This last problem is number 5. Let's write number 5 down, okay? Here we go. The integration from 0 to 5 of 3x squared plus 8 dx. Once again, we want the delta x, b minus a divided by n. We're then finding our c sub I, x sub I, which is going to be a plus delta x times I, and we are constructing the limit as n approaches infinity for delta x times the summation as I starts at 1 and goes to n for our f of c sub I. All right, here we go. Find delta x. 5 minus 0 is 5 divided by n. C sub I, which is x sub I, is going to be 0 plus 5i over n, which I'm going to simplify to 5i over n. The limit as n approaches infinity for 5 over n times the summation as I starts from 1 to n, and I'm going to use my bracket 3 parenthesis, 5i over n, the quantity squared, plus 8. Notice this is a little bit easier than some of the problems we've already done because there is no a value except 0. When we have an a value of 0, we're just left with a monomial. But if a is anything other than 0, we have a binomial and are forced to FOIL. Let's go ahead and continue. The limit as n approaches infinity of 5 over n times the summation, and this is going to give me 25 times 3 is 75i squared over n squared, plus 8. We're now going to distribute our terms. So the limit as n approaches infinity of 5 over n times, hang on, let's pull out that 75 over n squared, please. 75 over n squared times the summation of I squared, plus the limit as n approaches infinity for 5 over n times the summation as I goes from 1 to n of 8. Once again, we're going to replace this piece right here with n to the third power divided by 3. Notice it's always 1 power higher than the I. So if I have I squared, I'm working with power of 3 divided by 3. Limit as n approaches infinity. And now we have to multiply our 75 times 5. Now this is 325. 375, excuse me. Don't forget to carry your value, Mr. Lamb. This is divided by n cubed, multiplied by n cubed divided by 3, plus the limit as n approaches infinity of 5 over n, and this is going to be replaced with 8n. N cubes cancel, n reduces. This piece back here is 40. This is 375 divided by 3, and that is 125 plus 40, and my answer is 165. I'm now going to check my answer by going to my calculator and plugging it in. I have math 9 from 0 up to 5 for the function 3x squared plus 8 dx, enter. And you'll notice I get 165, the same answer that we got. Alrighty, there you go, Hornets. That was our classwork that we did today. I hope this has been helpful to you. If it has been, please make sure you click like so that I know it is an effective video. If you had problems, you can either come in and let me know, and we can work with it at lunch or after school, as I am available at both times. Hopefully, this was very good and useful to you. Thank you very much. Please remember, Hornets, it is easy to be mean, so please work hard to be nice to each other so that we may change our world, change our country, and change our school community into a more inclusive and positive and accepting one, where racism and bigotry are left behind in the distant past. Thank you very much. Be safe and be kind. Bye-bye, Hornets.